Welcome students to the chapter Surface Area Volume. In the previous standard, you have studied extensively about two-dimensional objects like squares, rectangles, triangles, parallelograms and polygons. Now we shall deal with three-dimensional objects that include cube, cuboid, right circular cylinder, cones which has length, breadth and height. We will also deal with the combination of 3D objects. Now let us look at this slide first. Three-dimensional objects, cuboid. The curved surface area, total surface area and volume of a cuboid are given here. Cuboid has length, breadth and height. Curved surface area thus is equal to 2h into L plus B. Total surface area is equal to 2 into length into breadth plus breadth into height plus length into height, which is equal to 2 into LB plus BH plus LH. Volume is LBH. Cube, it has a side and curved surface area is 4 into side squared. Total surface area is 6 into S squared and volume is S cube. Right circular cylinder, top and bottom surface closed, is equal to curved surface area is equal to 2 pi r h and total surface area is equal to 2 pi r into h plus r. Volume is equal to pi r squared h. Sphere, closed sphere, curved surface area is 4 pi r squared. Total surface area is 4 pi r squared. Volume is 4 by 3 pi r to the power of 3. 4 by 3 multiplied by pi r cube. Now hemisphere solid. Now r is radius. Curved surface area is 2 pi r squared. Total surface area 3 pi r squared. The top surface being closed. And volume is 2 by 3 multiplied by pi r to the power of 3. Hemispherical shell. It has got internal radius r, external radius capital R. Then curved surface area outer is 2 pi capital R squared. 2 pi small r squared is curved surface area, inner surface. Then total surface area is 2 pi capital R squared plus 2 pi small r squared plus ring area pi multiplied by capital R squared minus small r squared bracket closed. Volume is 2 by 3 multiplied by pi multiplied by capital R cube minus small r cube. Hollow cylinder pipe. It has got an external radius r capital R and internal radius small r. Then curved surface area of this hollow pipe is 2 pi capital R h CSA outer, 2 pi small r h CSA inner. Then total surface area is equal to 2 pi h into capital R plus small r plus 2 pi into capital R squared minus small r squared. Volume is equal to pi capital R squared h minus pi small r squared h. Spherical shell, r internal radius small r, capital R external radius. Then curved surface area is 4 pi capital R squared CSA outer, 4 pi small r squared CSA inner, and total surface area 4 pi capital R squared plus 4 pi small r squared. Volume is equal to 4 by 3 pi multiplied by r to the power of 3 capital R to the power of 3 minus small r to the power of 3. Now let us see the next slide, which is about the combination and or removal of solids. Right circular cone mounted on a right circular cylinder. Here the curved surface area of the cone is pi RL, curved surface area of the cylinder is 2 pi RH. So pi RL plus 2 pi RH is the surface area of the solid. So here H1 and H2 have been distinctly identified because cone has a different height than the cylinder height. The volume is simple formula. Volume of cylinder plus volume of cone is the total volume of the solid. That is 1 by 3 pi r squared h plus pi r squared h. Right circular cone mounted on a hemisphere. The surface area is curved surface area of the cone plus curved surface area of the hemisphere. This is the outer surface area. That is pi RL plus 2 pi r squared. L is equal to slant height of cone, which is given by the Pythagoras theorem. L squared is equal to h1 squared plus r squared. Volume of cone plus volume of hemisphere will give the total volume of the solid. That is 1 by 3 pi r squared h1 plus 2 by 3 pi r cubed. Conical cavity being drilled out of a right circular cylinder, surface area is equal to curved surface area of the cylinder plus bottom area of cylinder plus curved surface area of inside cone. Therefore, 2 pi r h plus pi r squared plus pi rl. Volume of this solid is volume of cylinder minus volume of cone, pi r squared h minus 1 by 3 multiplied by pi r squared h. Cone attached to both ends of right circular cylinder. Now, right circular cylinder height is h1 and cone height is h2. Therefore, the surface area is equal to curved surface area of two cones plus curved surface area of cylinder. That is 2 pi rl plus 2 pi r h1. Volume is equal to volume of two cones plus volume of cylinder, that is 2 multiplied by 1 by 3 multiplied by pi r squared h2 plus pi r squared h1. Hemisphere attached to both ends of a right circular cylinder like a capsule. Surface area is curved surface area of cylinder plus curved surface area of two hemispheres. 2 pi r h plus 2 into 2 pi r squared. Volume of cylinder plus volume of two hemispheres pi r squared h plus 2 multiplied by 2 by 3 pi r cube. Hemisphere drilled out of a right circular cylinder. Now surface area is curved surface area of cylinder plus bottom surface area of a circle plus CSA of inner hemisphere, that is CSA of inside hemisphere. 2 pi r h plus pi r squared plus 2 pi r squared. Volume here is volume of cylinder minus volume of hemisphere is equal to pi r squared h minus 2 by 3 multiplied by pi r cube. Cuboidal wooden cricket stump stand. Length is equal to L, breadth is equal to B, height is equal to height of cuboid, L1 is equal to slant height of cone, and slant height of cone L1 squared is found by R squared plus H2 squared, square root of R squared plus H2 squared is equal to square root of L1 squared, slant height. Surface area is total surface area of cuboid minus 3 area of circles plus curved surface area of 3 cones for holding stumps. 2 into LB plus BH plus LH minus 3 pi r squared plus 3 pi rl1 inside curved surface area of 3 cones that hold stumps. Volume is equal to volume of cuboid minus volume of 3 cones for holding stumps, that is LBH minus 1 by 3 pi r squared h2 multiplied by 3 cones. Right circular cylinder drilled out of a cuboid. Total surface area of cuboid minus 2 circles drilled out top and bottom plus inside curved surface area of cylinder, that is 2 bracket LB plus BH plus LH bracket closed minus 2 pi r squared, 2 circles drilled top and bottom plus 2 pi r h1 curved surface area of the inside cylinder. Volume is volume of cuboid minus volume of cylinder, LBH minus pi r squared h1. Hemisphere mounted on a cuboid. Surface area of cuboid minus area of top circle plus curved surface area heavy spherical dome. 2 into LB plus BH plus LH minus pi r squared plus 2 pi r squared. Volume is equal to volume of cuboid plus volume of hemisphere, LBH plus 2 by 3 pi r cubed. Here imagine that you are running your finger across the remaining solid, then you can derive the results better. In the remaining slides, you will see the two-dimensional objects surface area which you have learnt in the earlier standards, and this will help you to recapitulate areas of two-dimensional objects. Thank you.